evaluate I is equals to, you have integral of x cube minus 1 whole to the power of 1 by 3 x power of 5 into dx. X cube minus 1 whole power of 1 by 3 x power of 5 into dx. Now the question is, which value I need to take as t? That's the question. If I take x cube minus 1 from x cube, you will not be able to get x power of 5. From smaller power, you cannot get a greater power. But from a greater power, you can get a smaller power. So possibility is that I can take this as t. But if I take this as t, if I try to differentiate x power of 5, derivative of x power of 5 will be what? It is 5x power of 4. Power 4 should be there, but you're having power 3. What has to be done? That's the question. So which means that I had to simplify in this way and try to make this value also in terms of x power of 3 or x power of 4. That is what we need to do it over here. Rewrite this one. X cube minus of 1 to the power of 1 by 3. So the least power that you can make, however x power of 5, you cannot take it as t. But the question is, can I put this as t? So this is ruled out. But can I take this as t? But if I take this as t, differentiation of d by dx of x cube will be what? 3x square, which means x square should be there here. So x cube should be there and x square should be there. Both should be there. Only then you'll be able to integrate this one. So can this x cube, x power of 4, whenever the bases are the same, powers can be added? X power of 5. That is, this value he has given. So can I convert this x power of 5 back in this form, x cube into x square, so that I can solve this problem? From now on, if you want to solve any problems on integration, you should be alert and your brain should work. Only then you'll be, till now it was plain simple problems, direct problems. From now on, a bit of analysis you have to do whenever you're trying to solve the problem. Because I have decided that I'll be taking x cube as t, I have to put x power of 5 as x cube into x square. I'm just breaking that one. X power of 5 is written as x cube into x square into dx. So that if I put this as t, all right. So if I put this value as t and this value as t, I have to get that x square term. Let's put the value of x cube to be t. If I try to differentiate this one, derivative of x cube will be 3x square and differentiation x square will be getting. So x cube differentiation is 3x square into dx is equals to what? Is equals to dt. But what you're having over here, you're having x square into dx. Therefore, what you can write is, you can write x square dx to be equals to dt. X square dx will be equals to what? Dt by cross multiply, dt by 3. So now you try to plug in this value back there in the given integral and see what can be done over here, right? So if you just try to plug in there, I is equals to, you got it as integral of, sorry, x cube is what? X cube is t. T minus 1 to the power of what? To the power of 1 by 3. Then x cube value is what? X cube value is t into x square dx. X square dx is dt by 3. Here t minus 1 is there and t is there. So one should be the derivative of the other if you want to once again go for substitution method. Here the power of t is 1. Here the power of t is 1. So whenever the power of t is 1, here the power of x was 1. Here, can you observe? The power of x was 1. The power of x was 1. So what we have done, in the denominator we had x plus 4. Numerator also we have brought it as x plus 4. This is in terms of x, but now we are getting in terms of t. Here you are getting t minus 1. You have to make this value also as what? This value also as t minus of 1. Right? Both the values have to be made as t minus 1 itself if you want to solve this one. because directly you cannot simplify this one. Therefore, I'll try to simplify this. Divided by 3, I can take it outside and write down t minus of 1 whole power of 1 by 3, subtracting 1 and adding 1. Okay, now I'll try to group t minus of 1. So if you try to group this one, it is 1 by 3. It is t minus of 1 whole power of 1 by 3. I'll try to group this. T minus 1 I'll try to group. Plus this one I'll try to separate into dt. I think this divided by 3 I've already taken common outside. Now what has to be done is, once I have grouped this grouped value has to be multiplied by this t minus 1. So this will be 1 by 3. It is integral of t minus of 1 whole power of 1 by 3 is multiplied by t minus of 1. That is one product. Again plus you are having. Plus again multiply this value t minus 1 whole power of 1 by 3 with 1. So you will be getting another value which is t minus of 1 whole power of 1 by 3 multiplied by 1 will be t minus 1 whole power of 1 by 3 itself into what? Into dt. Now since there are two terms over here, I need to apply the integral separately for each of the term. 1 by 3 integral of. Now this is t minus of 1 whole power of. This is 1 by 3 and this is power 1. So this becomes t 1 by 3 plus 1 into dt I can multiply. This dt will come inside. So 1 integral plus again 1 by 3 for the second term. 1 by 3 is outside. Integral of t minus of 1 whole power of what? Only one term is there, to the power of 1 by 3 into dt. Or further, if I try to simplify this one, 1 by 3 integral of t minus of 1 whole power of 1 by 3 plus 1 will be 4 by 3. 4 by 3 into dt plus 1 by 3, it is integral of t minus of 1 whole power of 1 by 3 into dt. Again, if you want to make the substitution over here, you can make the substitution. Put the value of t minus 1 to be some other term u. Both are t minus of 1. Now let us try to differentiate. Differentiation of this t will be dt minus 1, the constant will be 0, is equals to derivative of u will be du. Therefore, dt will be equals to du. So go back to the given integral. 1 by 3 integral of t minus of 1 will be u power of 4 by 3 into dt will become du plus 1 by 3, again integral of t minus of 1 will become u power of 1 by 3, dt will become du. We know this formula, integral of x power of n into dx will be nothing but x power of n plus 1 by n plus 1 plus the constant c. If I use it, 1 by 3 u power of n value is 4 by 3, 4 by 3 plus 1 divided by 4 by 3 plus 1 plus 1 by 3. Again, u power of 1 by 3 plus 1 divided by 1 by 3 plus 1 plus the constant of integration c, or 1 by 3 u power of 4 by 3 plus 1 will be 4 plus 3 is 7, 7 by 3 whole divided by 7 by 3 plus 1 by 3 into u power of 4 by 3 divided by 4 by 3 plus the constant c. But we know the value of u. What is the value of u? You have u value is t minus 1. Over here, u value is t minus of 1. So put the value of u as t minus of 1. This 1 by 3 as it is, 7 by 3 will become 3 by 7. So u value is t minus of 1 whole power of 7 by 3 plus 1 by 3 into 4 by 3. When it comes to the numerator, it becomes reciprocal. U value is t minus of 1 whole power of 4 by 3 plus the constant c. You can further simplify this one. This 3 and this 3 will get cancelled. This 3 and 3 will get cancelled. But what is the value of t that I have taken initially? If you go back, t value over here, I have taken t as x cube. So put the value of t as x cube. So you will be getting the value as x cube minus of 1 whole power of 7 by 3 plus this 1 by 7 is there. I'll write 1 by 7 as it is. Here you are having 1 by 4. T value is x cube minus of 1 whole power of 4 by 3 plus the constant c. So initially the question was in terms of x. Finally, you have to express the solution also in terms of x only. That's the required solution. That's what. T value directly will not be able to find out. This was the question, right? First, I decided that I'll be taking this value as t. First, I decided because x power of 5 is there, it is independent. I thought of that. I thought of taking that as t. But the moment I try to differentiate here, it has become x power of 4. The moment you try to differentiate, this value which is there should appear here in the question, because everywhere, wherever you have to try to differentiate, what we have got that value there in the question itself. For example, here x square was there. When I try to differentiate 2x square, I got x dx. 2x square, if I try to differentiate, I got x dx, right? So when you try to differentiate that one, its derivative should be present there. That's the formula you're having. But in this case, what is happening? X power of 5 is there. X power of 5 is there. But the moment I try to differentiate x power of 5, I'm getting x power of 4 here. But there is no x power of 4. So that will fail. Therefore, I decided differentiating x cube. If I differentiate x cube, I'll be getting x square. But x square is also not there. That will also fail. Now the question is what to be done. But x cube you can take t. But if you want to take x cube, how can you express x power of 5? So therefore I have expressed x power of 5 in terms of x cube. I have written this 5 as I have to get 3. So 3 plus 2 will give you x power of 5. So further I have written it as x cube into x square. And we know when I take x cube, this as t, I will be getting its derivative, x square. Therefore, this is one of the possibility where I have expressed x power of 5 as x cube into x square. Then I have decided x cube as t. So one first step will not be able to identify which value has to be taken. So you have to use some methods here. So first I have checked with x power of 5, that was not possible. Then I checked with x cube, that was also not possible because x square was not there directly. So I have thought of getting how to get x square. The only possibility is by splitting x power of 5. When I have splitted this x power of 5, it has become x cube and x square. And x cube I have taken t. The moment I have taken t, I am getting that x square into dx. Its derivative value. This is how you need to decide. But the moment you see the problem, you will not be able to get it. Alright. One way is power is high. First set of problems that we have done. Power is more. Power is more means like you are having x square, its derivative is present as x. X cube is there, its derivative present as x square. X power of 4 is there, its derivative present should be x cube. But if the power is less, in that case, the less power value you are taking it as t, more power reduced to less power. More power reduced to less power value. That is what I have done. This method I have adopted because this was not possible for us in this problem. So these are the two possibilities that you remember. When power is more, the moment you try to differentiate, you'll be getting that value. But when the power is less, when you're not able to get the value, then try to check whether the more power values like x power of 5, can you reduce that in the smaller power form? These are the two possibilities you have to check. Only then you'll come to know that you have to take how to take t value. Getting it?
Yes, sir.
Just by seeing the problem, you'll not be able to get it. You have to check 2 to 3 steps to arrive at the result that which value has to be taken as t. Getting it? Just try to practice this once again at home. Try to change the powers and see what are the other possibilities that you'll be getting in this case. So if you want, you can try with this one integral of x square minus of 1 whole power of 2 by 3 into, and we take this as x square means you have to get this as x cube into dx. You try this one as a homework. You'll get an idea on how to adopt this procedure.